Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 7 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 3363. Find the maximum number of fruits collected. Okay, so let's make this problem easy. So first, let's read the problem statement. There is a game dungeon comprised of n into n rooms arranged in a grid. You are given a 2D array fruits of size n into n, where fruits ij represents the number of fruits in the room ij. 3 children will play in the game dungeon with initial positions at the corner rooms 0 0 0 n minus 1 and n minus 1 0. Okay, so let's understand this line first. All right, so now if you see this example number 1, this is fruits array given to us. Okay, so let's make this matrix first. Okay, so here what is the size of this? 1 2 3 4. Okay, n is equal to 4. So what we have 4 into 4 matrix, right? So there is a game dungeon comprised of n into n rooms. Okay, n into n, right? Okay, all right. So now here let's do the same thing here. So 1 2 3 4. Okay, so let's make these 4 into 4 rooms. All right, this one line, this one line, and this one line. Okay, and here also 1 2 and 3. All right, so now here if I just give the indexing here, okay, so I can say that this is my row 0, row 1, row 2, and row 3. Same way this is row 0, row 1, row 2, and row 3. Okay, so this is 4 into 4, right? 4 into 4. So I can say that this is nothing but my n minus 1. Okay, and this is also nothing but my n minus 1. Okay, and here in this side what I am writing rows, and here in this side what I am writing columns. All right, this is done. Okay, so now here fill these values 1 2 3 4. Okay, so this is nothing but row 1. Okay, so row 1 is at 0 index, right? So here row 0 you can say 1 2 3 4. All right, so here let's fill this 1 2 3 4, and here 5 6 8 7. Okay, 5 6 8 7, and then we have 9 10 11 12, 9 10 11 12. Okay, and then we have 13 14 13 14 15, and then we have 16. Okay, this is done. All right, now here it is saying that 3 children with initial positions at the corner rooms 0 0. Okay, 0 0. So let's say 0 and 0. Okay, so this is the position of let's say child A. Child A. Okay, 0 0. Done. This is done, right? And then 0 n minus 1. N is 4, so 0 3. At 0 3 we have child B. 0 and 3. So this is the position of child B. Okay, child B. Done. Now after that n minus 1 0. N is 4, 4 minus 1 3, 3 0. 3 0 is this point. Okay, 3 and 0. So this is the position of child C. Okay, child C. Okay, this is done. Okay, so I hope that this line is clear. Now after that the children will make exactly n minus 1 moves according to the following rules to reach the room n minus 1 n minus 1. Okay, so this is the destination room, right? N is 4, 4 minus 1 is 3, and 4 minus 3. Okay, minus 1 is 3, so 3 into 3. Okay, so that means that this 3 into 3. Okay, this is nothing but the destination room. Okay, so let me write here destination room. Okay, this is clear. All right, so now also one more point. the children will make exactly n minus 1 move. Okay, n minus 1 means 3 moves. Okay, 3 moves only, right? N minus 1. Okay, all right. And this is our destination. Okay, so we have to reach here. Okay, so now here, okay, now here if you see the child starting from 0 0. Okay, so let's say child A. Okay, this is nothing but for child B, and this is for child C. All right, the child A starting from 0 0 must move from their current room ij to one of the rooms, that is I plus 1 j plus 1. Okay, so if I and j is 0 0, okay, if I and j is 0 0, then this child A is moving to room I plus 1 and j plus 1. So I plus 1 and j plus 1, that simply means 1 1. Okay, 1 1 1 1 is available here na, this side. Okay, this, okay, right, 0 0 and then 1 1. Okay, that simply means that this position, okay, he can move to this position. All right, this is done. Okay, now here after that I plus 1 j, I plus 1 and j, I plus 1 means 1 and 0. Okay, 1 0, 1 and 0, this, okay, this way. All right, and here if you see next 0, and here j plus 1, 0 1. Okay, 0 1 also he can move, 0 1, that means this direction. Okay, so child A is moving in 3 directions. Okay, this and this. Okay, so I hope I am right here. Okay, 0 0. Okay, if I take 0 0, so 1 1 1 0 and 0 1, that's it. Okay, all right, so here just tell me one thing. I'm starting from here and I want to reach to this destination, and I can only make n minus 1 3 moves. Okay, so what is the shortest path here? First tell me what is the shortest path. This is going to be the shortest path if I move like this, something like this. Okay, or this is going to be a shorter path if I move like this. Okay, something like this. Or this is going to be the shortest path. Tell me, this is going to be the shortest path, right? Direct. Okay, shortest path. So if you just refer this shortest path only, okay, if you just check this shortest path only, so here also this is in one move. Okay, one move here, right? This is second move and this is third move. Okay, and we already know that a child can make exactly n minus 1 moves. Okay, so in the shortest path itself we are getting 3 moves. So definitely in these paths there will be more than 3 number of moves, right? So that makes this path as invalid, that makes this path also invalid. Okay, so for child A it is very simple now, he can just move diagonally only. Okay, 1 6 11 and 16, that's it. So for child A output is going to be 1 plus 6 plus 11 plus 16, all the diagonal elements. So what is the value that I'm going to get here? 6 plus 11 17, 17 plus 1 18, and 18 plus 16 is nothing but 34. Okay, so 34 is what I'm getting. Okay, for child A. Okay, 34. So here they have not, no, I have not written. Okay, so this is 34. All right. Okay, so 34 means I have collected this, I have collected this, I have collected this, and I have collected this. Okay, so this is for child A, and child A can move in these many directions. Okay, now let's see for child B. Okay, child A is very simple. Okay, done. Now for child B, he is starting from 0 n minus 1. Okay, 0 and n minus 1, that simply means from here. Okay, done. The child B starting from 0 n minus 1 must move from their current rooms. Okay, so let's say this is 0 3, move from their current room, okay, to one of the rooms. All right, so here I plus 1 and j minus 1. Okay, so we have 0 3. So here if I do I plus 1 and j minus 1, j minus 1 means that previous column and I plus 1 means next row. So here I will get 1 and here I will get 2. Okay, so see 0 3 and 0 3 from here 1 2. Okay, so this direction. Okay, this. All right, here you can move. All right, and I plus 1 j. Okay, I plus 1 next row and same column, so that simply means 1 and 3. Okay, 1 and 3, so 1 and 3, that simply means this way. Okay, done. And here I plus 1 j plus 1, I plus 1 is 1 and here 4. Okay, this direction 1 and 4. All right, so these are the ways, right? Okay, so this or this. Okay, definitely we are not going to move here. Okay, this time, because this is going to out of bound, but we have these two choices. Okay, we can move here, here and here. Okay, done. This is for child B. All right, now for child C, which is starting from n minus 1 comma 0, n minus 1 if I say 3 comma 0, right, must move from their current room ij to one of the rooms, that is. Okay, so if I write here 30, okay, let's say 30, so I am moving I minus 1. I minus 1 means previous row, but j plus 1 here means next column, so that simply means this direction. Okay, so here I will write 2 and j plus 1 is 1. Okay, done. I means same row and next column, so that simply means this direction. Okay, 3 and here 1 and here I plus 1 and here j plus 1. Okay, I plus 1 next row and okay and next column also, right? So here that simply means 4 and 1. Okay, so for this we can move here, that is nothing but 2 1. We can move to this 3 1 and we can move to 4 1. Okay, definitely we are not going to move to 4 1. Okay, out of bound. Okay, so only these two choices. All right, okay, clear, this is done. Okay, so here we have covered the directions that we are going to follow and we are clear, we have made the diagram. Okay, all right, next point. When a child enters a room, they will collect all the fruits there. If two or more children enter the same room, only one child will collect the fruits and the room will be emptied after they leave. Okay, but we need to return. We need to return the maximum number of fruits the children can collect from the dungeon. Okay, that's it. All right, so here you already know that child A has collected 1 6 11 and 16. Okay, so now child B or child C, okay, they can't collect these fruits. Okay, the fruits which are available at this position. Okay, done. All right, now here let's focus on this child B. Okay, let's focus on this child B. So this child B, okay, so he has two options. Okay, 4 is there. Okay, we are starting from here, so 4 will be there, right? And now in this 4 I have two options. Maybe I can, for at if I'm at this particular position, maybe I have collected this 4 in the past and then I have collected this 8. Okay, this, or maybe in the past I have collected this 4 and then I have collected this 7. Okay, so if I collected 4 and now 8, what is my new value that I'm going to get here at this particular position? That is going to be 12, right? Okay, and same way here, if I'm 7, okay, if I have 7 and previous time I have collected 4, so what is the value that I'm going to get? 11. Okay, done. Only two options, right? Here from 4 I can move to this or this side. All right, so this is done. All right, this is done. Okay, so now here, once this is done, okay, so now next time from this 8, okay, from this 8 you can only go to this side. Okay, or you can go to bottom, but bottom we can't collect. Okay, or you can go to this side. All right, or you can go to this side. Okay, so from 8 you have these many options, this or this. Okay, same way for 7, what are the options you have for 7? For 7 you can go to this and this. Okay, so now here for this 8, okay, if I'm here, okay, this is nothing but 12. Okay, new value 12 and here new value is 11. Okay, so if I'm at 12, okay, definitely I can't go here. I can't go here, right? This I have already collected. Okay, I have already collected. So even if I go here now, there is no benefit. Okay, because I can't collect this, right? And here at this particular position, okay, I can't go here. Okay, if I go here, then there is no benefit. Okay, I have already collected this. Okay, but child can move, right? When a child enters a room, they will collect all the fruits there. If two or more children enter the same room, only one child will collect the fruits. Okay, so I have already given this many fruits to this child A. Okay, previously. All right, now here this, and for 11 this is automatically invalid. Okay, because we are going out of bound. Okay, so only this option we have. All right, this option we have. For 12 also, okay, this 12 we can move this. Okay, this option we have, and we have this option also. Okay, right. Okay, now here, if you move to this, okay, if you move to this from 12, if you move to this side, if from 12 you move to this side, so what is the value you are going to get here? You are going to get 24. Okay, here in this position. Okay, all right, so here you are getting 24. Now from 11, if you come down, what's to 12, what are you are getting? You are getting 23. Okay, right? Okay, now from here 12, if you go here this direction, so what you are going to get? 12 plus 10, 22. Okay, and then here if it becomes 22, then you have this many options. You can go here, you can go here, you can go here. You are not reaching the you are not reaching the destination. Okay, your steps is increasing and you are not able to reach this. Okay, you are not able to reach this, so definitely I'm not going to follow this path. Okay, I have only this option. Okay, this option where's one valid path, or this one. Okay, so what I'm getting 24 and 123. I need to take the max one only. Okay, at this position when I'm reaching. So from here in the past I have collected 12. If I follow this route, I have collected 11. So definitely I will take the bigger ones when I'm going to reach to this position. Okay, so I'm going to get 24 here. Okay, and after 24 I'm going to reach here, and here I've already collected the fruits. That's it, I reached my destination. Okay, so how many steps I am following here? I'm following this route. Okay, 1 8, then I reach here 2, and then I reach the destination. Okay, 8 12 and this 16. Okay, so 4, then I've collected this 8, then I've collected this 12, and this 16 I have already collected in the past. So here what is the output that I'm going to get? 12 8 20, and here 24. Okay, this is done. This is done. All right. Okay, this is done. All right, so from here, see, from here, this is my source. Okay, if you see here carefully, from here this is my source and this is my destination. Okay, so I have found the best route. Okay, and in that best route I have ignored this. I have ignored this route. Okay, because then I will not be able to reach the destination. Okay, if I'm following this, because it is given that we can only take exactly n-1 moves. Okay, we can only make n-1 moves, right? So here if you see, this is my diagonal. Okay, this is my diagonal. 1 second, this is my diagonal. So if I follow this path, okay, or if I follow this path, 1 2 and then 3, okay, I am always in the right side of this diagonal. Okay, so if you cut this matrix in half, so I'm always in this side only. I'm always in this side only, right? If you notice this. Okay, for the best route, if I have to ignore these positions. Okay, I don't want to move to this position. Okay, if I move, then definitely I'm going to take more than n-1 number of moves. Okay, and that is not right. Okay, so we have to remain in this side only. This is the second finding from here. Okay, this is done. All right. Okay, so here for this one we have to remain in this side. Okay, so if you see the diagonal elements, we have what? We have this diagonal, right? 0 at 0, then we have 1 1. Okay, then we have 2 2. Okay, then we have 3 3. Okay, and I am saying that we have to start from this next position. Okay, we have to ignore this diagonal elements because we have already corrected the root from this next. Okay, from this next. Okay, so there is some column from where I have to start. Okay, there is some column here also from where I have to start. Okay, there is some column from which I have to start this arrow. Okay, this arrow started from some column, this arrow is also started from some column only. Okay, starting point. Okay, there is one starting point here, there is one starting point. Okay, one column, one column. Okay, one column is a starting point, one column is a starting point, and I'm saying that this column is the after this diagonal. Okay, so here if you see, my row and column both are same, my row and column both are same, row and column both are same, my row and column both are same. Okay, so in my main diagonal, row is equal to column. Okay, and now if I ask you to start from the this pointer, okay, this pointer, so I can say now this column is nothing but, I am starting from nothing but, I can say row plus 1 if I already know the value of row. Okay, row plus 1, right? Okay, because both row and column are same, right? Okay, so if both are 0 0 here, the next time column is going to be row plus 1, that is 1. Okay, if both are 1 1 here, then next time column is nothing but 2. Okay, so here starting point is 2, starting point is 1. Okay, so 0 1. Okay, here this is nothing but 1 2. Okay, the starting point. So here when both are 2 2, so I can say column is nothing but 2 plus 1 3. Okay, so 3 2 comma 3 is the starting point. Here let's say 4 comma you can say 3 comma 4 is the starting point. Okay, so here I've derived one thing, column is equal to starting from row plus 1. This is what I have derived here, column is equal to row plus 1. Okay, just note this point. Okay, this is done. Now here one more thing, let's say n value. Okay, let's say your n value is equal to 7. Okay, 7 into 7 matrix we have, 7 into 7, 1 2 3 4 5. Okay, 1 2 3 4 5 6 and 7. All right, and here also we have 7 into 7, right? 1 2 3, then 1 2 3 4 5, 2 more. Okay, so let's say this here also same thing, 7. Okay, so here we have 0 1 2 3 4 5 6. Okay, 0 1 2 3 4 5 and 6. All right, so I have told you guys that we are always going to remain on the other side of this diagonal. Okay, on the other side of this diagonal we are always going to start from here. Okay, here, then here. Okay, this is what I'm saying. All right, so here I can make my solution a little bit more faster. Okay, how? So if you see here, if I'm starting from here, here I have this choice. Okay, I have this choice, I have this choice. Okay, only at this position only I can go, right? So here if I just draw one reverse diagonal as well. Okay, so this is main diagonal, so if I draw the reverse diagonal, if I draw the reverse diagonal here like this. Okay, so if you see now, these are the wasted columns. Okay, I'm not able to reach. If I'm starting from here, I'm not able to reach here. Okay, so why do I need to check from here? Okay, at this position only, this is my starting point. Okay, child B is starting from here only, and he can only move to this side or this side. Okay, if you just ref check this row 1. Okay, then why I need to check this? Okay, there is no need, right? So I can say whatever the max. Okay, so here this value or this value, what is the max? This is the max, right? Okay, just see the red color pencils. Okay, this and this, what is max? This. Okay, this point. Here start from here or just start from here, which is best? This is the best point. Okay, because I can reach at most here only, right? Okay, next time if you are here, you can start from here or you can start from here. Which is best? This is best. Okay, because even if you reach here, next time you are only going to reach here only, right? Okay, so why do I need to check this? Same way, if once to reach here, so start from here or from here. Okay, for this main diagonal here, so you have to take then this one, right? the max value, because I told you that we don't need to cross this. Okay, if we cross this, definitely we are going to take more than n minus 1 moves, right? So here we need to start from the max of, okay, column value. Okay, if I am here in row 1, then my column value is going to be the max of this point or this point. Okay, max of this point, sorry, this point. Okay, this point is nothing but I can say row plus 1. Okay, and this point. All right, so how I'm going to find this row, this point? Okay, how I'm going to find that? So main diagonal, you already know that we have 0 0, we have 1 1, we have 2 2, then we have 3 3, then we have 4 4, then we have 5 5. Okay, and here if I just move a little bit here, we have 6 6. Okay, this is the main diagonal. Now reverse diagonal. So reverse diagonal, if you see, we have 0 6. Okay, then we have 1 and 5, 1 and 5, then we have 2 and 4, 2 and 4, then we have 3 into 3. Okay, then we have 4 comma 2. Okay, 4 comma 2 here, and then we have 5 comma 1 here. Okay, then we have 6 comma 0. Okay, this is the reverse diagonal, right? Just this is the reverse diagonal. Okay, so these are the points. All right, these are the points. Okay, and this is your main diagonal. Okay, so in the reverse diagonal, if you see, what is the sum of this? 0 plus 6, sum is 6, this 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 sum is 6, right? In the reverse diagonal, so sum is 6. Okay, and we are getting this sum by doing this: row plus column is equal to 6. Okay, and 6 is nothing but, in this example my n is 7 now, right? So 6 is nothing but n minus 1, I can say. Okay, so now from this formula, if I calculate the value of column, I will get what? I will get n minus 1 minus row. Okay, so my column is going to be, okay, when I'm going to check for this row, my column is going to start from, I can say, math dot max of row plus 1, or here column value coming out as n minus 1 minus row. Okay, so this is the formula that I want to derive here. Okay, so I hope that this is clear. Okay, now this is done, n minus 1 minus row, that's it. Okay, this is done. All right, so this is how you are going to calculate this. Okay, for this child B. Now how we are going to calculate the child for child C? So I don't want to write the code for child B and then another code for child C. I want to use the same code. I want to use the same code. Okay, so how I'm going to do that? I'm going to transpose this matrix. Okay, so how I'm going to do the transpose? Okay, what is the meaning of this transpose? All right, so here if you see, in this child A, I have used diagonal elements, and for child B, I'm using the elements which are available on this side. Okay, and for child C, I'm going to use only these elements. Okay, so somehow if I shift this part here to this part, okay, and then apply the same code which I applied for child B, I will get the answer, right? If I just copy this code, okay, whatever the values here to this side. Okay, how I'm going to do that? Let me show you. All right, so here how I'm going to change that, let's see. So we have 4 into 4. Okay, so here let's say this is nothing but your 4 into 4, 1 2 and 3 lines are there in total. Okay, here also 1 2 and 3, so we have 0 1 2 3, 0 1 2 and 3. Okay, so now here 1 2 3 4. Okay, so what I'm going to do here, 1 2 3 4, I'm going to write this 1 2 3 4 like this row. I'm going to just change it to the column. Okay, 1 2 3 4, that's it. Okay, 5 6 8 7, I'm going to write like this: 5 6 8 and 7. 9 10 11 12, I'm going to write like this: 9 10 11 and 12. Okay, and 13 14 15 16, I'm going to write like this: 13 14 15 16. Okay, so now if you notice one thing here, 1 6 11 16. Okay, same main diagonal. Here in this side what we have, if you see, in this side we have this 2, okay, 3, okay. So here if you see, we have 2, we have 3 here, we have 8 here, we have 7 here, we have 12 here, okay, and we have 4 here. So see, all the elements come to this side, okay, for child B, which I have already used, right? And for child C, if you see, starting point is 13, okay, so 13 automatically comes here, okay, to this position, right? So this is what we need to do, right? So from here again I have to start. So for this one also same logic, this, okay, and we have to remain to this side only, okay. So we are going to get, so 13 10, what is the value I'm going to get? 13 10 23, okay. Or if I do 13 and 14, what way I'm going to get? I'm going to get 27, right? So now here I have to reach 15, okay. So for 15, 23 is bigger, 27 is bigger, 27 is bigger, absolutely, right? So 27 and 15, what is the value that I'm going to get? 7 and 5 is nothing but 12, okay. 2 3 4 42, right? Okay, so this is what I'm going to get, okay. So now here, that means here if I just write 13, okay, 13 14, this is what I have right now, 13 14 15, okay. 13 plus 14 plus 15 and plus 0, so I'm getting what? 42. So now if you do the total, 4 4 8 9 10, okay, 1 here, 3 4 5 6 7 8 9 10, okay, 100, right? 4 5 6 7 8 9 10, 100 is the output. If you see, 100 is the output, okay. So here there is one mistake by LeetCode. Here see, 1 2 3 4, then 5 6 8 7, then 9 10 11 12, okay, then 13 14 15 16, 13 14 15, here they have written 1, okay, by mistake, right? So output is 100 only. So here don't get puzzled with this diagram, okay. It should be 16, not 1, right? Okay, so that's it. So this is what we need to do, okay. So I hope that you guys are clear with the explanation. Right, now let's move to the coding part, and I'm also going to explain the code line by line, okay, so that this problem becomes easy, right? Hard to easy, okay. So now let's write the code. All right, so what we need to do here first, so first thing, here just calculate the n value, okay. So int n is equal to fruits dot length, this is done, and then the total number of fruits, okay, total fruits, this is what we need to calculate, okay, total number of fruits we are going to collect. So here let's say 0. Then after that, diagonal path, okay, child from top left to bottom right, okay. So diagonal path, so here I'm going to say child from top left to bottom right, okay. So here for this one we have to collect all the diagonal elements. All right, so simple loop I'm going to write int I is equal to 0, I is less than n, I plus plus, okay. And here what I need to do, total fruits is equal to fruits of I, okay, and here I 0 0 1 1 2 2, okay. So this is going to my main diagonal, right? Okay, so now after that we have to check the path from top right to bottom right, okay, for child B, top right to bottom right, okay, this. So what we need to do here, from top right to bottom right, okay. So here I'm going to first add the comment, okay, path from top right to bottom right, okay. So here you need to write total fruits, okay. There should be some feature, okay, in LeetCode, like if I'm writing TOTA, okay, it automatically complete to total fruits, okay. we are wasting a lot of time in completing the variables. Let's raise this issue to LeetCode. So here I'm just going to call one method, let's say compute max path. Okay, the path, okay, I'm going to call this, I'm going to write the one method, okay, compute max path, and I'm going to use the same method for both child B and child C. So in my compute max path, I'm just going to pass the number of fruits that I have and n value. That's it. So here, from here, let's say I'm going to get the total fruits for my child B as well, right? Now after this I have to just transpose the grid to reuse the logic for bottom left to the bottom right. Okay, so here transpose the grid to reuse the logic for bottom left to bottom right. Okay, and here I have to just write transpose. I'm going to call this method transpose, and I'm just going to pass the fruits. Okay, I'm just going to transpose this matrix completely. Then after that I will calculate the path from bottom left to right, bottom right. Okay, bottom left to bottom right. Okay, after transpose, same logic I'm going to use. That is why I'm just going to transpose this. Okay, so here I'm just going to call this again, total fruits equal total fruits plus compute max path fruits n. Okay, and I'm going to return total fruits. See, again we are wasting a lot of time here writing complete word again. All right, if there is such feature, then there is no possibility of mistakes as well, right? Okay, so this is done. Now after that, let's write these methods. Okay, so first I'm going to write dp to compute, you can say max fruits collected by one child, avoiding the diagonal paths. Okay, both the diagonals. Okay, avoiding the diagonal paths. So this is also going to be very simple. Okay, and not get worried now if here I'm using the dp word. Okay, so we are using dp only in this problem. All right, now here private int, this method is also very easy, nothing tough, compute. Okay, if you are clear with this part, how we are writing call as math.max row plus 1 and minus 1 minus row. Okay, this is the only complex part, but if you understand this, then this problem is very easy. Okay, so here compute max path, here what you have to pass, you have to just pass the fruits. Okay, which is nothing but a 2D array. So here fruits and here n, and now inside this int. Okay, so first I am here now. Okay, so let's say this is my priv, then next time I'm going to fill this, okay, my cur. So when I'm going to reach to this, so I'm going to use this as my priv, and then this is going to become my cur. Okay, so priv and cur logic I'm using here. So int priv is equal to new int and, all right, and here int cur is equal to new int and this is done. Now here just we need the max value, right? So what I'm going to do, I'm just going to fill this priv and cur with minus infinity, let's say integer mean value, right? So here I'm just going to use arrays dot fill. What I'm going to fill, I'm going to fill priv with integer dot mean underscore value. Okay, same way copy this, paste it here and here for cur. Okay, cur is curr, all small. Okay, now after that here my priv and cur. Okay, so if you notice here I'm starting from here na child b and I have to reach here. Okay, but next time, okay, if I'm here now, next time I'm starting from here, this row, okay, I'm already here, but next time I'm starting from here now, right, from this row, and my destination is here, okay, and this I have already covered. So mainly I have to check this part, okay, this part and this part. We have to check. Let me use this sky blue color, let's say. Okay, yeah, this part and this part, this I have already collected, and here I am in the starting. Okay, this I have already collected. So basically I have to check these two only, right? So I can say that my row is starting from 1, okay, 4. I'm going to use for loop, okay, and yeah, I'm starting from here, all right. And if I'm starting from here, then this is going to become my cur, and this is going to act as my previous, right, if I'm starting from here. So in my prib I'm already here, okay. So let's collect these fruits as well, okay. So what I'm going to do here, I'm just going to write priv, okay, whatever the my priv, in that n minus 1, okay, the last column. So in that last column, what is the value available? So I'm just going to collect that, okay. Fruits 0, 0 row, and column is n minus 1, okay. So this is nothing but my starting point. So here I'm start from top right corner, okay, start from top right corner, okay. So here this priv I have minus infinity, I have minus infinity, I have minus infinity, and here instead of minus infinity I have operated the value as 4, okay, because from priv, okay, from this priv this 4 is coming, right, and this 4 is the value, okay, that I'm here in the starting, okay. Now I have to reach here. So in when I'm going to reach here, so from this priv I'm going to pick this 4 now, okay. So I have this path, I can move here, I can move here, okay. These are the paths, right? So that's why priv I have it like this, okay. And now you already know that my row is going to start from 1, and I have to check, I have to run until here only, okay, until here only. I don't need to check the last one. So last one is nothing but n minus 1. So n minus 1, previous one is n minus 1, n minus 2, okay, previous one, right? I have to run until here only my rows, okay. I have to check this row only. So I can say less than n minus 1, right? So here I'm writing row is less than n minus 1, okay. And here row plus plus, done. And same way you already know how I'm writing the columns. Int col is nothing but here math dot max, all right. And here I'm writing n minus 1 minus row, okay. Or here I can simply say row plus 1, okay. You already know how we had derived this, okay, from here. And column value, okay, so here it should be less than your n, and column plus plus, okay. This is done, okay. This is done. Now here max fruit, okay, max fruit is coming from top, okay, from here. So max fruit I can say that priv and this value, okay, column this value, all right. So I can say my max fruit is nothing but max fruits is nothing but priv col, okay. This is done. Now after that, okay, after that, if I am reaching here now, so for me fruits are coming from here and from here, okay. These three are the choices, okay. For this 8 is there, okay, this 8 I am here. Now previous, so for previous I have values coming from here, I have two values coming from here, I have values coming from here, right. These are the values that we are coming, okay, from this side, from this side, from this side. These are minus infinity only, but we need, and here this is 4, we need among them the max value. So max is 4, okay. For this 8 there are 3 possibilities, but we need the max among these 3, okay, and that is 4. So in 4 I'm going to add 8, I will get 12 here in total, okay. So this is what I need to do here. So max fruit is equal to priv col, and here if I'm just going to write if my column is greater than 0, okay, column is greater than 0, here 0, then in that case your max fruit is going to be, max fruits is going to be the max value, math dot max of max fruits, and here priv col minus 1, priv uh, priv here, and here col minus 1, okay. So col minus 1, that simply means this side, okay, from this side, col -1, okay, for this 8 this side, okay, from this side. So if I'm checking this side now, I have to make sure that this side is there, okay. If this side itself is out of bound, then we don't need to check now. So that is why I'm writing first if condition, col is greater than 0, okay. So if my col is greater than 0, only then I'm checking, okay. If it is 0, then 0 -1 -1, okay, that is not valid, okay. If code is greater than 0, let's say 1, then it is valid. Priv 0 will be there, some value, okay. Minus infinity maybe, but some value will be there, okay. So this is just a full boundary condition. Same way, if call is column value is, it should be less than n-1, okay. If it is less than n-1, then I'm going to update my max fruit as, just copy this line, paste it here. Max fruit is equal to math.max of max fruits, okay. And here call +1, call +1, okay. So for this 8, value is coming from this, okay, from this side and from this side, okay. So I have checked all the possibilities, okay. So here is minus infinity, here is minus infinity, and here is 4. So whatever the max, okay, which side the max value is coming, okay. So if you see this part, code is less than n-1, so max fruit is going to math.max of max fruits, and priv of column +1. Column +1 means next, okay. So if I am here now, so next column is this, okay, and here we have 4, okay. So here we have to update 4, okay. So here initially my max fruit is going to priv call. So priv call is nothing but, here I'm writing priv call, it should be like this now. Why I'm writing like this, priv call, okay. So my call is starting from this, okay. So priv upper value, okay. So here I'm writing the upper value, okay, upper value. So first time when I'm at 8 now, so I'm going to get minus infinity, okay. From this is upper, this is, you can say, left upper, maybe left side upper, and this is nothing but right side upper. So right side upper, you are going to get the max value, okay, for the very first time. So whatever the value you are going to get, okay, so you have to update the current call. Call is equal to, okay, at current position at call, okay, 8 I have to update as 12, okay. So max fruit, whatever the max fruits that we are coming from top, in that, the at the current position, what is the value of fruits, okay, how many fruits you have collected. So here you are going to write row call, and we are also making sure that we are never touching the diagonal as well, okay. Done. This is done, okay. We are not touching the diagonal, so there is no need to change the collected fruits to 0, okay. Since here 1 6 11 12, and we are always remaining, we are checking only these elements which are remaining, okay. Here we are checking these many elements, so no need to change that as well, okay. So this is done, okay. So once this is done, okay, then for the next time, okay, first time this is my priv, this is cur, next time this is going to become priv, this is going to become cur, then next time priv, this and cur, okay, like this it's moving, okay. So here I am just going to swap current and previous row arrays, okay. So here you have to write int temp is equal to priv is equal to cur, and here you have to write cur is equal to temp. That's it, okay. So we have printed this, and from here in the end, what you need to return, you just need to return priv n-1, okay, whatever the value that you have here in priv n-1 in the end, okay. That's it, okay. So this is done. So now this is also done, okay. So from here, from this, we are just going to return the max number of fruits that we have collected in this path, okay. So here, how many fruits you have collected? So you have collected 24, okay. So now after that, we are just going to transpose this, and then again just going to run the code, okay. So now we have to just write the code for transposing this matrix. That's it, okay. Only few lines are pending now, okay. So here utility to transpose the matrix, okay. Let me add the comment, utility to transpose the matrix, okay. So very small code for this one, private void, and here transpose, and here you have to write int matrix, okay. And here int n is equal to matrix dot length. Okay, and here you have to write the code. Int I is equal to 0, I is less than n, I plus plus. Okay, so if you notice, we are not changing the diagonal elements. Okay, we are just changing the elements which are before that diagonal to other side. Okay, we are just keeping them to other side. Okay, so here this is also one very important question, how you are going to transpose the matrix, okay, in this single loop, okay, like this, using this swapping, right? You don't have to create a new matrix. Okay, so in interview they will ask, you have given one matrix, transpose it, but condition is you don't have to create a new matrix. Okay, in the same matrix, using same matrix only, you have to transpose it. Okay, so this question is actually asked to me in one of my interviews. Okay, in Microsoft, I think so. In Microsoft, during Microsoft interview, they asked me this question. Okay, how you are going to transpose the matrix, but you don't have to create a new matrix and then use that matrix. Okay, so you have to use the same matrix, right? So how you're going to do that? So that is very simple here. Okay, so int temp, here you have to write matrix, and here you have to write I and j. Okay, and then here matrix, and here I and j, and here you have to write matrix j, and here I. Okay, and here matrix j and I. Okay, and here just change it to temp. All right, so now if you just check this code, it will automatically swap the elements. Okay, so it is going to put the elements, like here we have this now, so it will automatically change the order. Okay, so this is very important. Okay, this itself is very important, this part important. Okay, so that's it. Okay, that's it. So now let's run the code and see if there are any code issues. Try to fix that. So yes, there are some issues at line number 25. Okay, let's check line number 25. For int column is equal to math.max, this call. Okay, here I'm writing like this. All right, so here we need to change it now, like this. All right, let's run it again. So see, all the test cases has been accepted, right? Nice. Now let's submit it. So see, our solution is accepted, right? Okay, so I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.